It's been a long time since I did a tech update on the XVE engine, and not a lot has been going on graphically. What I've been doing is reworking all of my base uh, engine support stuff. So this is string manipulation, mathematics, some formatting stuff, logging, threading, and I've been expanding my tests. I build everything with a set of tests. And so I've got things that now do time callbacks. I've got a thread pool that's working. I've got a task dispatcher, async loaders. And this is the piece I'm now working on for my ECS. And my ECS is a completely separate part of my engine. It's not part of the base class, but it uses the containers. And the containers that I've got a whole bunch of const expr containers. I've got a const expr hash. I've got const expr arrays. I've got const expr map where I can add things for compile time. I've got tests for all these. And then the containers themselves are in my types area. So I've got dirty flagging, types. So the AVL tree is used to take an index type and store something against it. And obviously an AVL tree is to give you an optimal lookup time. Each of my nodes have a left and a right, and we go down it. Now, I don't like that I'm still using raw pointers, but it was getting on my nerves using it. I've just noticed that height here doesn't have M height, it's just height. So I need to fix that. I'm not sure why that's like that, unless I've made this a function at some point and I've changed it, but whatever. They're both templated on each other, so the tree can take anything of that type. And as you'll see by the name that being AVL2, this is my second attempt at implementing it. This here being my first, actually. And this had the node within and a whole bunch of stuff, and the left-right rotates and all that's jibbery jabbery. But I didn't get it right. And so what I've now done is written a support class that lets me output an AVL tree as a dot graph. And these output into my runtime directory. So if we look at my containers test on the left here, we can see that I insert and create a empty tree. Well, let's have a look what the dot for an empty tree looks like. So we open it with photos, and it looks like nothing. Yay! So what's the next piece of code? Let's park the tree over to the right, and let's look at the code. So the next piece of code is to insert A at index 0. It's a bit of a cheat. It could have been any index whatsoever. Oh look, we get an A at index 0, and it's got null pointers. So now we insert B. B is going to be a higher index. It should appear on this right-hand side. And there it does. It appears on this right-hand side, and it has 2 null pointers. So now I'm going to insert D as 3. This is distinctly different. So D as 3 would go into this position here, which means the tree would rotate. That means B would become the root. Sure enough, B becomes the root. So we can now see that it's rotated the tree. I'm now going to insert C as 2. So that would bring it to the left of D. That wouldn't be a rotate. It wouldn't be quite fully out of balance. So I'm expecting it to go to this location here. And sure enough, it does. So now we've got C to the left of 3D. And we've got 2 nulls here. We've got 5 nulls in total for the 3 nodes. So now I'm going to insert 2C. So that should, 2C, 10K, that's going to go to the right of D here, filling in this part of the tree. And it does, it goes to the right of this. So 9J. Now, is 9J going to rotate this whole section, or is it going to go down here? Let's see. It rotates the whole section. We rebalance the tree, look. We've gone to the root of 3 to be the root, and we've balanced the left-hand side to the right-hand side because we were just out of step. We add F. We can see F fitted in nicely here, and we add E. E goes down the left-hand side here. We haven't rebalanced this yet, and I could go on and on and on. I'm really, really happy with how this implementation's come along, and this is going to speed up my iteration and the insertion of entities and types into my ECS, because I'll always have the or a very efficient lookup rather than having to serially look at something. My SparseSet to packed set storage will be exactly this stuff, and I'm really, really, really happy with how it's come along. So I will be expanding on this some more. Expect to see more of my SparseSet and my actual entity component system in the next few days. And this is just, I'm just so happy this works for 9:30 on a Monday night. This is a really positive step for me. I've worked on this AVL tree on and off for about 2 weeks because my initial implementation was a little bit naive. You'll see that I use raw pointers as well in the end here for brevity. I was using unique pointers, but I just got in such a bit of a clacky mess with moving and move semantics. It became hard to read. So now I've got the implementation working, and especially the rotates. The rotate left and right are very important to look this way. So the X to the Y, and then the bits and bobs. I used... oh, let me give them credit. Let me look up the reference I used. It was Geek for Geeks. So Geek for Geeks reference is where I then... So I initially read about AVL trees. I had to work through them, but then I used Geek for Geeks, and I'll put this website in the description if it ever works. There we go. So this was Geek for Geeks explanation, and the balancing and insertion here. These actual diagrams are really good. They really explained to me well what I was doing, how to do it. It's been a long time since I've just sat down and played about with an algorithm, so it was good fun. It was really, really good fun. So Geek for Geeks. I'm now going to expand the tree a bit more. I'm going to work on deletion. Some more items, but the printing, I like the printing. So I've just got a basic, it literally just outputs the dot file, as you can see here. So let's look at the 8th one, and it's got landing. So I output each node with a value, and from those values I also then output a null pointer with a unique value going from max int down, and I connect them together at the end. So as we're done with each node, we connect to any other node, and down we go. So 3 goes to 9, 9 goes to 5, 5 goes to 4, so on and so forth, down and down and down. And that builds us a graph type with the shapes of circles. They're 0.7. The ordering is out to get the correct left-right ordering in the tree. And obviously you saw the dotted style. So that was all I did to get myself to what I think is actually quite a pretty looking graph, which I quite like how this comes out in the end. Lots of places say that there aren't ways of representing this tree well in dot language with Graph Viz, but there is. You just use the out ordering. So sorry for rambling for nearly 9 minutes. There's my small tech update for AVL trees in my engine. For a little bit more of footage, let's actually run my test suite and show you what we got. So these are callbacks that test on 1,000 callbacks being set up and happening. This is for event transmissions. These are timed callbacks. So these happen after an amount of time. This is going to run for 1 minute now. So we're at about 20 seconds. So I'll keep talking. The important one is a test where you'll see 3 separate counters being atomically counted up to max int, unsigned max int, 4 billion, whatever it is, 4 trillion. And that test is of the thread pool. There are also system graph. There's a system graph. So each system can be ordered to action after another system with a set of dependencies. So we'll go down each step. Now, I quite like this node type tree, and I'm wondering about balancing this tree, providing a way of saying, hey, this system actually accesses whatever entities, and it does its thing. So there we go. There's my SparseSet test. So the SparseSet I've got does stuff as well. In fact, the SparseSet test is right here. These are the SparseSet tests. So this is indexing one thing to another. So this is the old SparseSet that I'm going to be replacing with the new AVL tree. And all printed is the output of this. Here we go. Here are the basic tests for my string handling, test handling. This is a message test. So there's actually a way of passing messages around the system. This is a serialization test. This is the thread pool test you see running now. So it's outputting its value. And here's the system. So they're updating. Each of these updates on the right hand side, each double bar is like an end of frame almost. It is set to run at a certain frames per second for this. It would be running 30, 60 plus. But there you go. As my test suite run and completed, I've got 273 tests in 22 scenarios, all successful. And I use DOCTEST as my testing framework. I quite like DOCTEST. It's used at the in my workplace. It's used on the project that I'm on professionally. I've got quite used to it and quite enjoy using it. So thank you for watching this. Sorry that it's been so long bringing you another tech update, but this is just being fitted in the time I've got, and I'm a very busy chap at the moment, and I will see you all soon. Do subscribe if you've not already. It really, really helps me, and we're getting close to that magic 1,000 people. If we get over 1,000 people, I'll spend like a good weekend on this and go through a whole bunch of the code. So how about that? Get your friends involved. Get everybody involved. Get me to 1,000. Speak to you all soon, and until then, stay safe.